Hi everyone. In today's lesson I'm going to teach you about how to solve quadratics in vertex form. Okay, so just a bit of a definition here. Although we've done solving before in this class, I just want to remind you that when I say solve, when you see the word solve, that means that for a given y value, we're going to find the associated x value. And when we've done, up until now, we've done linear equations. So for example, finding the solution of a linear system. So if we had a y value, there would always be one x value. You're going to see, though, when we do quadratics, there can actually be more than one x value. So I'm going to put x values with the s in parentheses there to remind us that there can be actually more than one solution. Graphically, this is where we're talking about, what we're talking about here is where a parabola intersects with a line. And in the simplest case, this is where our parabola, which might look like this, I don't know, let's say it's over there, intersects with a horizontal line like this. So what we're really doing is we're trying to find out where are those two points of intersection there, okay? And notice that there are in fact two. So let's do that. So what I've done here, folks, is I've set up a system where I have a quadratic here, and that quadratic is given by this equation with four different transformations. I have a reflection, a vertical scaling, and two translations, which altogether gives us this shape here. Then I have my horizontal line, y equals -4. Here it is. And what I'm really looking for is the points of intersection. So you'll note I have two of them. And this first one, the x value has to be a little less than 2, like 1.8 or something like that. You can tell because this one here has an x value of 2, so this one has to be a little less. And likewise over here, this one should have an x value a little greater than 6 by the same reasoning. So I really like graphing these. It's usually pretty straightforward if your equation is in vertex form to just do a quick sketch. I really find that powerful because it gives me an idea of what my x values ought to be and as a consequence what I need to be looking for. So now what I'm going to do, however, is I'm going to go through how to find those x values algebraically. I mean, again, I have an idea of what they ought to be, but I just want to know to make sure that my algebra matches my graph. Okay, so I've got my system here. I've got my quadratic and my line, and so the very first thing that I'm going to do is I'm going to make the y value of my line equal to the y value of my quadratic. So this guy's got to be -4, and the rest stays the same. All right, and then I'm going to go through, and the first thing to solve algebraically is I need to subtract 6 from both sides. And so then this gives me -10 equals -2, x minus 4 squared, and this pair here is zeroed out. Then I'm going to divide both sides by 2. Divide both sides by 2. So again, on this side, that's divided out, and on the other side, on the left side, I'm left with 5. Okay, so now here's the thing. I need to undo this squaring term here, right? This term here is squaring, so I need to undo that, and the opposite of that is square rooting. So clearly, I'm going to square root the right side. So fair enough. However, and this is what a lot of people forget, when you square root a number, so I'm going to have to do that over here. When I square root a number, however, if I use my calculator will give me back a positive number. So when you square root 5, for example, you get around 2.2. But actually, there are two answers, two numbers that when squared give you 5 as a result. 2.2, that's one of them, but also -2.2. So it's really important that when you square root a number, you write down plus or minus to account for the two possible answers, positive square root 5 and negative square root 5. You'll see in a moment why that's so important. Okay, so now that I've done that, my next line becomes plus or minus square root 5 equals x minus 4. And then last thing, I'm going to just skip up here for a second. Last thing is this actually produces two possibilities. So I'm just going to rewrite this here. Plus or minus square root 5 equals x minus 4. And I'm going to break these into the two possibilities. First of all, if I have square root 5 equals x minus 4, I add 4 to both sides, and so I have 4 plus root 5 equals x. And since I've already said root 5 is about 2.2, this gives me around 6.2. And then the other possibility is if I go through with negative 5. Okay, negative 5. And so then in that case, I'm going to go 4. Oops, I forgot my root sign. 4 minus root 5 equals x. And again, if 5 is around 2.2, this is 1.8 approximately. All right. So those are my values, 6.2 and 1.8. And if you go back and look at the graph that I had earlier, you'll see that those do indeed match the graph. I have to have two answers. I have to have two answers because there are 2 points of intersection. And those two answers come about as a result of square rooting 5, right? These are the plus or minus rather. So I have this plus or minus, that gives me one possibility, minus root 5, that gives me another possibility. And there have to be two. Okay, so I'm going to leave you now, but I want to leave you with 3 questions. And you can see that in the example that I've done, I did it graphically and I did it algebraically, and there were 2 solutions. But will there always be 2 solutions? Well, spoiler alert, no, there won't always be 2 solutions. But have a think about, when will there not be any solutions? In other words, when will the parabola and the line not cross one another? And there are circumstances where that doesn't happen. And then this is the really weird one. When will there be exactly one solution? Right? When will there be one solution where the line and the parabola only intersect once? Okay, have a think about that, and we'll talk more about it in class. See you next time.